Hey, welcome to the ninth session for section 1.3, part 2, limits at infinity and asymptotes. All we're going to do now is just really talk about asymptotes as we already talked about limits at infinity. For right now, we're going to deal with two types of asymptotes, horizontal and vertical asymptotes. An asymptote is just a line that a function approaches but never really reaches. Vertical asymptotes have the form of x equals some value c and may be found by determining what values of x make the denominator in a rational function equal to 0. If this is true, then the limit as x approaches that value of c would be plus or minus infinity. Okay? It's important to notice that you must check the limit as you approach infinity, as you approach the value c from the left side and the right side, because you may have a one-sided limit, and that would be a vertical asymptote. Okay? So you need to check the limit as you come in from the left and you come in from the right. And we'll get more into that. Here's a quick example. Let's look at the function y equals 1 over x. Obviously, the function is undefined at x equals 0. As x gets very close to 0, y gets infinitely large. So if I come into 0 from the left side, in other words, negative numbers, okay, so let's say I come in very small to 0, like negative 1 over 10 billion, okay, then the limit of that would be negative infinity, okay. As I come into 0 from the right side, a positive 1 over 1 billion, when you flip that fraction, I would get positive infinity. So 0 would be an asymptote here, but on the left side, the y values would go down towards negative infinity, and on the right side of the line, y equals 0, x equals 0, the values would go up to infinity. Still an asymptote, however. Graph this just to verify. A horizontal asymptote can be found by taking the limit of f of x as x approaches plus and minus infinity. We did this in the homework just the previous session. If the limit is a real number, c, then there is a horizontal asymptote at y equals c. Okay, in the next slide, we're going to discuss some sample problems where we'll find the horizontal and vertical asymptotes. Okay, let's find the asymptotes, and I hope you can read this, of y equals x plus 3 over x plus 2. Clearly, this is a rational function. Y is undefined at x equals negative 2. Okay, so I'm going to take the limit of y as x approaches negative 2 from the right, from the left side, and I find that to be negative infinity. I'm also going to take the limit as x approaches negative 2 from the right side, and I find that to be positive infinity. Okay, therefore the line x equals negative 2 would be a vertical asymptote. Please note that it doesn't have, just having one of these limits be infinity or negative infinity is enough to say that it's a vertical asymptote. Now let's take the limit to find a horizontal asymptote. Let's take the limit as x approaches positive and negative infinity. The first thing, if you remember, is you divide the top and bottom by the highest power of x in the denominator. That would be x. So I divide the top and bottom by x, and what I get is 1 plus 0 over 1 plus 0, which would be 1. Therefore, y equals 1 would be a horizontal asymptote for this function. So just to recap, this function would have a vertical asymptote at x equals negative 2, and it would have a horizontal asymptote at y equals 1. Okay? Not so bad. Here's another sample problem. Okay? This one we're going to throw a curve at you. F of x equals negative x over x squared minus 4. Alright, first thing, let's find the vertical asymptote. It looks like this function might be undefined when x equals plus 2 or minus 2. Okay? So let's take the limit as x approaches positive 2 from the right. Okay, as x approaches positive 2 from the right, okay, that would be, obviously you know the limit's going to be either negative infinity or positive infinity. So your job is to figure out which without graphing it. So if I come in with numbers that are slightly larger than 2, because that would be from the right, then that denominator, okay, is going to be a positive fraction. So when I flip it, I'm going to get infinity, but the negative sign in the original problem would make it negative infinity, if that makes any sense to you. Okay, so the limit as x approaches 2 from the right would be negative infinity. Now, as x approaches 2 from the left, it's just going to be the opposite, because I'm going to have a number in the denominator that is slightly less than 4. Okay, I'm sorry, slightly less than 0, because if I take, so let's say 1.999, okay, and square that, that would be less than 4. And then subtract 4 from it, I'm going to get a negative fraction. When I flip that fraction, infinity would be in the numerator, but a negative infinity. Now, I have the negative sign in front of the 8. That's going to make it positive. So the limit, therefore, would be positive infinity. The same would be true, and you can try this on your own, when I take x equals negative 2 and approach it from the left and the right. Okay, so we would say that the limits of x equals x equals plus 2 and x equals minus 2 would be vertical asymptotes. If you graph this function, you'll see that there's like a u in between negative 2 and 0. I'm sorry, negative 2 and 2, and then the function approaches negative infinity on either end. Okay, graph it and check it. Okay, let's find the horizontal asymptotes for this problem. This isn't as hard, okay? Keeping our procedure that we used previously, we're going to divide the top and bottom by x squared. Okay, so when I divide the top and bottom by x squared, I get negative 8 over x squared over x squared minus 4 over x squared. Now I'm going to take the limit as x approaches infinity and also as x approaches negative infinity. Both of these will give me a limit of 0. Therefore, y equals 0 is a horizontal asymptote. Okay, not so bad. Okay. There's also another type of asymptote called an oblique asymptote. Oblique asymptotes are found by using synthetic divisions, which I think you may have had in Algebra 2, but have probably forgotten. To find the equation of a line that may be an asymptote to a function. We will do this in class because I'm going to give you a review of synthetic division, and it's a lot easier to do it in class than on this video. Okay? The next slide will show you the problems that you should be practicing on, and there will be a video quiz on this video tomorrow morning. Also, if as you're watching this video, I would like you to post your questions to me in Edmodo. Just go to a post, and that way I will see them, and we can bring these questions up tomorrow if you have questions. Okay? Here's your practice problems. Page 122, number 21 through 32. 21 through 24 are the problems that I said, inventing functions. We'll talk about that also in class, so we'll take care of that tomorrow. All right? Have a good evening.